What if you could drink a black hole? Let's say you wake up one morning, walk into the kitchen, and instead of reaching for a cup of coffee, you reach for a black hole. Not a picture of one, not a metaphor, a literal black hole in a cup that you're about to drink. Already you've got problems. First, you can't see the black hole in your cup. It doesn't glow, it doesn't steam, it doesn't even swirl ominously. It's just a weird empty spot where light seems to vanish. If you drop a sugar cube into it, you won't hear a plop. You'll hear nothing at all. The cube will disappear silently, like your last relationship. Now let's talk size. The smallest possible black holes, known as primordial black holes, might be smaller than a proton, but still have the mass of a mountain. The black hole in your teacup? Let's generously assume it's about the mass of Mount Everest. This, by the way, is a problem, because while your cup still looks fine on the outside, the gravitational field around it is now powerful enough to tear atoms apart. If you're even a few meters away, you're already being stretched into spaghetti. If you're closer, congratulations, you are spaghetti. But let's say, somehow, you survive this. Maybe you're in a futuristic lab with shielding strong enough to block gravity. Don't ask how, just go with it. You pick up the cup and sip. At this point, a lot of physicists are crying, because what does it even mean to drink a black hole? A black hole doesn't have edges or molecules or liquid form. You can't stir it, you can't dilute it, and you certainly can't swallow it. It's more like drinking a tear in the fabric of the universe. But let's say you try anyway. You put it in your mouth. The cup is gone. Your hand is gone. Your mouth is gone. You are gone. Okay, fine. Let's be more imaginative. Let's say you don't actually drink a whole black hole. Let's say you somehow extract a spoonful of black hole matter, whatever that is, and mix it into a smoothie. Is that better? No, it's worse. A spoonful of black hole contains roughly as much mass as Earth's entire moon, which means the moment you pour it into a blender, the blender falls through your kitchen floor, through the Earth, and emerges in Australia, dragging half the planet with it. Also, the spoon now has an event horizon. Don't lick it. But what if you could somehow isolate the energy of a black hole instead of its mass? Black holes emit a faint form of radiation known as Hawking radiation, a slow leak of particles from the edge of the event horizon. In theory, you could harvest this radiation over billions of years, collect the energy, and make what? A very disappointing tea? Actually, Hawking radiation is incredibly powerful, just slow. A black hole the size of a mountain would take longer than the age of the universe to fully evaporate. But if you had a tiny, fast-evaporating black hole, the energy released per second would be, and this is the scientific term, absolutely bonkers. If you could somehow bottle that energy into a drink, you'd have the most caloric beverage in history. A single sip would contain more energy than all the nuclear bombs ever detonated, multiplied by every cup of coffee ever drunk, and then sprinkled with Red Bull for flavor. Of course, if you did drink that, assuming your atoms weren't instantly vaporized, you'd be the most energetic creature in the cosmos. You wouldn't just run a marathon, you'd be the marathon. And also the finish line. And also the flaming crater where the city used to be. Now let's try a different angle. What if black holes themselves were drinkable in some hypothetical future? Like, introducing dark roast, now with 100% real singularity. Would this be the most efficient energy source ever? Yes. Would it solve the world's energy crisis? Absolutely. Would it also create a scenario where humanity casually carries micro-black holes in coffee cups? That's the end of civilization, because eventually someone would spill one. On the floor. Or worse, in a meeting. And then suddenly the conference room, and everything in a 10-mile radius, is just gone. No one would even have time to ask if it was decaf. So, could you drink a black hole? No, you can't. You can barely look at one. You certainly can't hold it. And if you ever did manage to ingest one, you wouldn't digest it. It would digest you. But in theory, if you could turn black hole energy into a consumable form, you'd have access to the most potent drink in the universe. Something between an espresso shot, a fusion reactor, and the wrath of the gods. And that, friends, is why Starbucks doesn't sell them. Yet.